So we have quadratic functions. So here you go. And what is the equation for that parent function?
Y equals x squared.
Y equals x squared, or I'm going to put p of x. So the parent function is x squared. And it's going to go through 0, 0, negative 1, 1, and 1, 1. So there is my parent function. I'm going to put some holes in the graph over here. So I'm going to put a hole at negative 1, negative 6, and I'm going to put a hole at 1, negative 6. So now we made it a little more interesting. So what is the domain of this quadratic function here? Infinity?
Negative infinity, positive infinity.
Negative infinity, positive infinity. Use what we talked about with this stuff up here. There's holes in that line, right? Okay, well we have holes in the quadratic here.
Okay.
So can it really go from negative infinity to positive infinity?
No.
Not with holes there. So where is it going from to where? Negative infinity to negative 1, yeah. And then what happens? Where does it start again? Negative 1 to 1.
Would it really be negative infinity, or would it just be 0?
Hold on. And then where? Is it negative infinity or positive infinity?
Positive.
Positive infinity. Okay, so you just said, is it 0?
Yeah, from the starting.
0's right here.
Yeah, so why does it go from negative infinity to negative 1?
Because it's starting somewhere down here. I don't know where it's starting. It's somewhere way down here.
Oh, lowest to highest. All right.
No, left to right.
Oh, left to right. My bad.
Domain, left to right.
Yeah.
So then we have the range. What is the range of this graph? Negative infinity to what? Why negative 6?
Oh, the holes.
The holes, okay? To negative 6. And then what? Negative 6 to negative 5. So why does this negative 5 here have a bracket? It's touching it. It is touching at negative 5. I'm going to draw you another quadratic. So negative 1, 1, 0, 0, 1, 1, 2, 4. I'm going to put a hole in this one. I'm going to put a hole over here at 4, 2. So what is the domain of this graph here? Good. Negative infinity to 4. And then 4 to positive infinity. What about the range? Okay, yeah, it starts at negative infinity to what?
2.
To 2? Okay. You're wrong. Why is he wrong? Does anybody know why he's wrong? Okay. So it's actually all the way up to 3. The reason he is wrong is because if I took the two ends of this graph and squished them together, would you have a line that has a gap in it? No. So every y value between negative infinity and 3 has been accounted for, right? So the range is everything between negative infinity and 3. So this one over here, if I took these two ends and squished them together, what would happen? There'd be a gap at what? At negative 6. Okay? So we would start at negative infinity, we'd get to negative 6, we have to stop, jump over it, and then go up to negative 5. This one, we don't have to do that because it gets covered up. Everything's accounted for. So we talked about writing negative infinity to positive infinity with interval notation, but we didn't talk about what to write if it's an inequality. So for this parent function here, okay, this quadratic parent function, where does it start on the left? Negative infinity. Where does it end on the right? Infinity. Okay, but if I'm going to write it using an interval, I don't want to use infinity. So what I use is the all real numbers sign. So my domain for that, I would have x equals, and then the thing for all real numbers, you just have an r with another line in it. So your domain is all real numbers for that. And then your range, I'd have y is greater than or equal to 0.